Hi everybody. I hope you're enjoying Hacktivity this year. And I'm going to start with a question. Do you play computer games? Yeah, okay. And those of you who play computer games, have you ever thought about getting hacked via the games you play? Well, I'm Thomas, and I'm going to talk exactly about that. But first, a few things about myself. I'm Tamás Szakály. I work for a pen tester, developer for a security company here in Hungary called PR Audit. I have an OSCE, and I am part of team Proditors who won the Hacktivity CTF 2 times and was the European champion of Global Cyber Olympics in 2012. Okay, what I do. My favorite quote from my favorite movie summarizes this quite well. I'm not a computer nerd, I prefer to be called a hacker. I do love tinkering in binary files. I love reverse engineering, I love crack meets and playing with copy protections. And one more thing I'm gonna tell about myself, and I don't want to start a flame war here, but I really prefer cute demons over flightless birds, half-eaten fruits, or pieces of glass in wooden frames. That said, I have to make a confession. I am, and I was for years, in love with the Win32 API. It's just so disgustingly beautiful sometimes that you just gotta love it. Okay, and this will be somewhat relevant later on. That's why I'm telling you this. So, games and security. I'm going to talk about game modding. Since I'm talking to a room full of hackers, I'm sure I don't have to tell you about that urge to make things better, to implement your own ideas. And yeah, game modding is basically the same principle. You have the framework, the game, and you want to do something more of it. And obviously, you want to share your creations. And there are huge websites where you can upload your creations and other people can download them and play your mods. Nowadays, you can even get paid for these mods, like on Steam Workshop. And I'm telling you this because I want you to be sure about that this is not some theory. So people do create mods and other people do download and play them. Okay, so games and security. An important aspect is multiplayer gaming. Since nobody likes to play alone, nearly all games have some kind of multiplayer functionality. What this means from a security standpoint, it means a constant data exchange between the client and the server, and this data often is quite large and quite complex. Think about whole levels or maps. And the protocol they use is often obscure, some kind of in-house developed protocol. So you should realize that this is a fuzzing heaven. And yeah, Rivand showed us in 2013 in an excellent talk that game engines are indeed vulnerable. They showed several exploits, several 0 days in several game engines. But I'm not going to talk about these kind of bugs. I'm going to talk about scripting, abusing scripting in games. So there's a lot of games that incorporate some kind of scripting functionality. Either they embed some existing languages like Lua, or they develop some own language, but it is there in a lot of games. It is there because it makes creating dynamic content a lot easier. And these scripting engines are often available to modders. So we can abuse them, but could they be really dangerous? Think about this for a moment. You create a map and somebody downloads it, or somebody joins the server and the mod or map gets downloaded to his machine, and the scripts that are in these maps or mods eventually will be run on that machine. And yeah, most of the game developers realize that this could be a threat, so they try to mitigate it, they try to implement sandboxes, but these sandboxes are often faulty. They can be easily circumvented. So if this is easy to exploit, that surely I'm not the first one to realize this, and yeah, I'm not. There are lots and lots of references about game exploits on the internet. You can see on the Salt exploits, several articles about garage mode exploits. So why am I talking about this if this is that common? I'm talking about this because game exploits are used to cheat in games, but they can give access to your PC, and through your PC they can give access to your home network, to your routers, to your security cameras, and so on and so on. And yeah, this is the part that nobody seems to talk about. Well, I'm going to now. My first victim is Crysis. Remember when I said that most of the game developers realized that scripting could be a threat? Well, Crytek is not one of them. They seem to believe what certain cyborgs said about the futility of resistance, so they didn't implement any kind of sandboxes, any kind of protections. They use Lua as a scripting engine, and you can call whatever you want. You can even call os.execute, which is used to execute OS commands in Lua. And I am going to show you this via a Crysis 2 mod I've created. I'm sure at least some of you dreamed about hacking something via just a push of a big red button. We are going to do that now, as soon as the game loads. Yeah, there are 5 games and 3 virtual machines running on this laptop now, so oh yeah, it's a bit slow. Okay, where you are? Okay, it's loading. Okay, so here we are in this deserted island, and there's a big red button. Wonder what happens when I push it. I push it, and yeah, a calculator-ish something started. So that's how you can execute code on a player's machine via a Crysis map. Well, how did I do that? I'm going to show you the code that is attached to the unused event handler of this big red button. It's here, and it really is this code, this one code, this os.execute. Okay, but what is this backslash blah blah thingy? It's one of the reasons I do love the Win32 API. In Win32, every API that uses files, file paths, can use UNC paths. And yeah, load library and shell execute are not an exception to this. So if you can call, somehow you can call these functions on your victim, you can load a DLL, or you can execute something from a remote share, so you don't have to write shell code, and so on and so on. And this has one nice side effect. Since it uses a Windows share, you can steal NTLM challenge responses. If you can try to load some files from a remote share, and yeah, I have a demo for this too. It's in CryEngine SDK, which is a much newer version of CryEngine than the one used in Crysis. I have it here, and I also have a virtual machine with a Samba server. It's an in-packet Samba server, and we're going to jump into the game. push the button, and yeah, you can see the NTLM challenge response here. Feel free to crack it. Okay. So, moving on. Okay, this was the demo. My next target is Dota 2. It's another Lua scriptable game, but it has some kind of sandbox. So you can't just call package load lib or OS execute, but it has a huge leak. The entire standard Lua IO library is available, so you can read files or you can write files. You can use the same SMB anti-hash stealing trick. You can steal files from gamers. You can deploy auto-run stuff, or you can do what I did in this demo, and it's only a video. I encoded my payload in a base64 form, and what I'm gonna do in this Lua script is decode an executable from this, decode the payload from this base64 string, and overwrite the Dota 2 executable with my payload. Now, this is the payload. It's actually a calculator. And we are starting the game. Yeah, it's only in the editor because I didn't have time to do this in the game itself. So the Lua script is attached to the NPC spawned event. So I'm going to spawn Kobold. And as soon as I do that, the game starts to decode the base64 string and overwrites the executable. So, oh, sorry. You're somewhere here. Okay, so we can see that the executable indeed got overwritten, and so the next time we start the game, it won't be the game that starts, but the calculator or payload. So that's how we can hack a machine via a Dota 2 map. Next target, it's called Digital Combat Simulator. It's a combat flight simulator. And I'm sure you know that lots and lots of exploits start out as crashes. Well, there will be a crash and there will be an exploit in this demo, but not the crash you see usually. Okay, so DCS also uses Lua for mission scripting, and they also have a leak. In fact, they had several leaks. I reported them. One leak, they fixed it in a few weeks, and I found this one, reported them, and they didn't respond, so I don't know what's with them. But I'm going to show you this leak, or rather, I have a beer for whoever can tell me what is wrong with this code. This is the sandbox implementation of DCS, and they have an error somewhere here. Okay, so nobody speaks Lua. Okay, so I'm going to tell you. The leak is on the 24th line. They try to disable loading DLL files into the address space. So they try to nail out the function loadlib. But it should be package.loadlib. Loadlib is nothing, it's already nil. So they achieve nothing with this line. So we can call package.loadlib, which is used to load DLL files. Okay, since nobody won the beer, I have backup questions. First one, the title of this talk is a quote. Who asked that question? Really? It's a classic hacker movie. Okay. Okay, I have another backup question. The answer is Joshua from War Games. Okay, backup question 2. What is my favorite movie? Oh yeah, you can have the beer. You can have it now. Okay, so this is the mission editor in DCS, and what I'm doing here is I've put up a mission where I've attached this Lua script to the plane crash event. So when my plane crashes, this gets called, it loads a DLL, and yeah, I am showing you this. Here's DCS. I'm going to hop into the cockpit of a TF-51D, hopefully. Okay, it's slow too. Oh, what the fuck. Sorry about this. I don't know. It's not responding at all. Okay, we are here. But it's not running. Please run. Please fly. No, it's not flying. This is my coolest demo, I think. Okay, resume. And nothing. Okay, so I'm going to try it again. So it's now full screen. Fly again. Yeah, the demo guys, they have something against me, I think. Okay. Okay, a few more seconds, I think. Yeah, and okay, it's going to work. Okay, I'm crashing. Yeah, I crashed, and yeah, here you are, paint. Okay, so, yep, it succeeded. And move. Okay, please don't be rude and go away. Okay, so here we are. And my next demo, it's a bit different than the others because in the others, the server is the bad guy and the gamer is the victim. This time the gamer will be the bad guy and the target is the Armed Assault game. It's a military combat simulator where you can have squadrons and you can customize your squadron information, your squadron name, your logo, and so on and so on. And these squadron information are visible not just for you, but for everyone on the server. And this works by you, when you set up your profile, you can set up URL to an XML file, and every time you join to that server, the server will fetch that XML file and parse your squadron information from that. So when I first read about this, I was sure it's vulnerable to XFC. And yeah, it was quite a disappointment that it was not. But it's still an SSRF, since you can get the server to load the URL that you provide. Okay, I'm going to show you this. By this setup, there's this guy having an Armed Assault server, and he has also a PHP charts server on that same machine for keeping stats or something like that. And PHP charts is vulnerable to a code execution that can be triggered via a GET request. And we are going to trigger that exploit. Okay, I have the game here, and somewhere I have listening. Okay, I'm listening here on port 4444, and I have my profile. This is the URL that triggers the PHP charts exploit. Yeah, you can see that it's a connect back shell. Okay, it's all good. Cancel, play, multiplayer. That's my ARM Assault server. We are trying to join it, and we are listening. There should be a connection anytime now. Yeah, and here it is. So we can see that it's really working. My M doesn't. Okay, so yeah, we got a connect back shell from the ARM Assault server by just connecting to that server. Okay, moving on. We used an HTTP GET request in the previous demo, but this HTTP request, to exploit this is somewhat restricted because you can't see the response and you can't control it too much. There are other games though where you can issue HTTP requests. Some of them, one of them is Garry's Mod, where you have this HTTP request structure and the HTTP function that uses this structure, and you can see that you can control every aspect of the HTTP request. You can control the method, you can control the headers, you can control everything. So what this means that you, as a modder, basically have a HTTP proxy to the gamer's machine, to the gamer's internal network. Yeah, I have a demo for this too. And why it's not running? Okay, it's running somewhere. Oh, here it is. So I'm going to start the game. I have a Garry's mod that I'm loading now. And I have implemented 3 console commands. First, these console commands can be used when you are a super administrator, and they are used for 3 things, obviously. First one being HCK scan players. It basically scans all the connected players network for HTTP devices, HTTP servers, and send back the result to the super administrator. And yeah, I just scanned my network, which is this game and this security camera. And yeah, it found the security camera on this IP address, but it requires authentication. Okay, no problem. I have another console command that can brute force HTTP basic authentication. It requires 2 parameters. First one is the player's ID, and the second one, okay, sorry, is the IP address. Not copy, paste, okay. And it's trying to brute force. You can see what it's trying, and yeah, it has found that the username is admin and the password is 2. So now we can have access to that security camera, and what my third console command do is steal a picture from that camera, and it requires the ID and the path for the image 2. I'm sorry, I'm just gonna cheat a little bit. Yeah, this should, yeah, I don't have the URL. This could be brute force 2 based on camera type and some other infos. But yeah, I'm terribly sorry, but I don't remember the correct URL, so I'm just gonna try this, and yeah, it wasn't that well. Okay, I'm sorry, I don't want to take any more time with this, but yeah, it was gonna be cool, so your image would have popped in the game. But yeah, maybe if I have some time after the talk, or I have some remaining time, I'm gonna try again. So sorry about that. So sorry about that too. Okay, so my last demo, you should be afraid of mice. And I'm not talking about those two guys, but they can be dangerous too. I'm talking about this one. This is a Logitech G whatever mouse, and like all Logitech G series peripherals, it can be scripted via the Logitech gaming software, and it can be scripted in Lua. It has a very, very tight sandbox. It's really not easy to circumvent it, but it's not impossible. There's a guy named Core6 who had a beautiful Company of Heroes 2 exploit back in 2013, I think. He abused handcrafted Lua bytecode. He dumped some Lua functions, modified the bytecode, loaded the function, and yeah, he did black magic with that. He used two tricks with these handcrafted Lua bytecode. First one being getting the memory address of any Lua variable as a double. And the second being creating arbitrary Lua variables that point to memory locations we want to read or write. These two combined means an arbitrary memory read-write, which can be used for code execution. Okay, how did he do these tricks? The first one, getting memory addresses. In Lua, every variable is a t-value. A t-value is a structure which first 8 bytes is either a pointer to an underlying structure, or in case of a Lua number, it's a double. So if we somehow can get Lua to interpret an arbitrary variable as a Lua number, then we can get the pointer, we can get that memory address. And yeah, it can be done with a for loop. For loop consists of two opcodes. The first being op for prep, which checks that all variables for that for loop are in fact numbers. The second op for loop is just the loop. So if we knob out the op for prep, then we can get Lua to interpret anything we throw at it as a number. So that's how we get memory addresses. The second trick, it's a bit more complicated. It's crafting arbitrary t-values. It's done in these few lines, and I'm going to go through this code line by line. First, we create a string that string in memory that looks like an up value. Up values in Lua are there to represent function parameters and variables that are declared outside of the scope of the function. So we create a string that looks like an up value and an up value that uses our memory location that we want to read or write. Next, we get the address of this string. we can get this with the first trick, and we have to add 24 to this because we can get the address of this T-string structure, but what we really want is the actual character array's address. And yeah, you can see that the first 24 bytes of a T-string is just some metadata. So we add 24 to this address and get the address of that character array in the upper PTR variable as a double. Next, we just concatenate 3 times that upper PTR and modify the Lua bytecode. So the variable magic, which is the upper PTR 3 times concatenated, will be interpreted as an L closure. And as you can see on the bottom part of the slide, bytes 16 to 24 overlaps the L closure's upwards field. The upwards field is an array of up-value pointers. And since byte 16 to 24 in our string is an up-value pointer, this will all be valid. So this is how we can access arbitrary memory addresses in Lua by modifying bytecode. Okay, what did Cortex do to exploit this stuff? He created a coroutine with coroutine.wrap, which creates a C closure on the Lua stack. C closure is basically a Lua representation of a native function, the native function being Lua B aux-wrap in this case. He simply replaced via the memory write the C closure's function pointer with LL loadlib. So when he called the coroutine with a DLL name, its DLL got called, so got loaded into the address space. What did I do differently? First of all, Cortex's exploit is a 32 bits exploit. Mine is 64. This is important because the memory layouts are different and the calling conventions are different. So function parameters are not pushed onto the stack. They use registers to do that. And the most important fact is that the size of a double equals the size of a pointer, which made this exploit much, much easier on 64 bits than on 32. Okay, and I couldn't load LL loadlib because you can compile Lua in an ANSI-only mode where LL loadlib is just a stub. So I had to call load library directly. How to do that? So the function, the native function we want to call, it's a prototype must match the C closure's function pointer. And yeah, it's load library or shell execute are good candidates because they have one parameter that is a pointer. So how do we call load library? Somehow we get load library's address. I'm going to talk about this in the next slide. Replace the Lua B aux-wrap with load library A, and we override the Lua state with the DLL name. Because the C closure's function pointer expects a Lua state as a parameter. When we override this and call load library, then load library will be called with the overwritten data. Okay, and yeah, last step, we have to call the coroutine. Oh, okay, there are some difficulties doing this. How do we get the Lua state struct's address. We want to override this, so we want the address. It turns out that coroutine.running gives you back the Lua state when you run in a coroutine. So the entire exploit has to be wrapped in a coroutine, and we can easily get the Lua state struct's address. Okay, when I did this, there were some random crashes, so I had to disable Lua debug hooks. I did that. There were some more crashes. And yeah, I stopped them by stopping the garbage collector and by restoring the Lua state. Okay, the most interesting part, how do we get the load library address? There is a simple solution. We can get the load library and the Lua B orgswrap functions address difference from the B executable file. And we can get the Lua B orgswrap address at runtime, and yeah, we can calculate the load library address from that. But that's not really nice solution, because you have to have the exact executable that you are trying to exploit. There are more generic solutions, and these work on Windows and on Linux and other operating systems too. On Windows, we can get the address of the NT header, because we can read memory. We can get from the NT header the address of the import directory. In the import directory, we can search for kernel32.dll, and when we found kernel32, we can get load library's address from kernel32's import address table. All this using those two tricks I showed you earlier. Okay, there are some restrictions to this exploit. We can only overwrite 16 bytes of the Lua state. But since we are loading DLS, it's not really a restriction. As I showed you earlier, we can load DLS from remote shares. And load library works like that. We can omit the .dll extension. So for b.dll, we can just use b. And yeah, basically, we can get 9 characters for an IP address, an AdBIOS name, or a domain name, which is quite feasible. So it's not really a restriction. Okay. Demo time, if it starts. Okay, I don't really know how much time I got, because I think it started a bit later. So. Okay, where you are. Okay, it's not running either. Yeah, I'm very happy. Wow. Okay, so I'm just going to finish this, and if you're interested in the demos, you can find me. I'm sure I can make them work, so you can see them if you want. So to summarize all this, should we listen to Joshua and stick to a nice game of chess? Of course not. We should play computer games because they can be fun. But we have to be security conscious even when we are playing. So don't download any kind of mods or maps from the internet, or just play on a computer that you use for nothing else. Do your updates. Steam does this right, so it forces you to update. This machine had to be offline for months because I didn't want Steam updates. Okay, and also game developers should really think about security in their games, because yeah, the state of security in games is really, really low. Okay, so thank you very much for listening to this talk. I hope you enjoyed it, and have a nice day. Thank you.